Everyone, we are from Sri Vishnu Engineering College for Women. This video is presented by Divya, Bhavya and Sri Soumya under the guidance of Dr. M. Prasad, PhD, Associate Professor, Department of CSE, SWEC, Bhimavaram. The contents we are going to discuss in this video are class and object variables, special methods, types of methods, and garbage collection in Python. I'm Sri Samya and I'm going to deal with the topics class and object variables and special methods in Python. First, class and object variables. Before knowing to the class and object variables, first of all, let's see what is a class. Class. In Python, a class is a blueprint or a template for creating objects. It is a fundamental concept in object-oriented programming. A class defines the structure and behavior that a group of objects will have. A class is defined using a class keyword followed by name of the class. The basic syntax is given here. Class, class name, and inside this class attributes are present. And we need to create object for every class that is created below. Object name equals to class name parenthesis. Let's see what is an object here. In Python, an object is an instance of a class. It is a specific entity that is created based on the structure and behavior defined in a class. An object represents a particular occurrence or realization of the class blueprint. In another way, we can say that object is a real entity of a class. Objects are created from a class using the class name followed by parentheses. This process is called instantiation. The resulting object is an instance of a class. The syntax is object name is equals to class name parenthesis. In Python, class variables and object variables are the two types of variables that can be defined within a class. Here is a brief explanation of each. Let's see what are class variables. Class variables are shared among all instances of a class. They are defined within the class, but outside any class methods. Class variables are accessed using the class name or any instances of the class. Changes to a class variables are visible to all instances of the class. They are typically used to store data that is common to all instances of the class. Class variables are defined outside the constructor, that is init method and other instance methods. Example. Here is an example that demonstrates the usage of class variables. Here we have created a class with a car which has a attribute of wheels. As we know, car have 4 wheels. We gave the attribute wheels equal to 4. Here class variable. Here wheels is the class variables as it is written before the constructor init. And we use constructor def init self comma brand. Self.brand equals to brand. Here brand is the parameter and this is the instance variable. And we created objects for class car, car1 and car2. Car1 equals to car of parenthesis of Toyota. Here Toyota is the attribute to def init method, which is the brand. And car2, by using the dot operator, we can access the attributes of a class. Print of car1 dot brand means here car1 brand is Toyota. Then we will get output as Toyota. And car1 dot wheels, we get output as 4 as class variables is wheels equals to 4. We can access the class variable with class name itself without any object, like car dot wheels equals to 4. Without. Let's see what are object variables. Object variables are unique to each instance of a class. They are defined within the class methods, typically within the constructor. Object variables are accessed using the instance name. Each instance of a class has its own set of object variables, independent of other instances. They are typically used to store data specific to each instance of a class. It can be understood clearly by using this example. Here also we used same example, class car, in which we created a constructor init self comma brand. Here brand name varies by with the objects we created. Car 1 and car 2. For car 1 we gave a brand name Toyota, and for car 2 we gave brand name as Honda. So when we print car1 dot brand, we get Toyota, and car2 dot brand we get Honda. It means brand name changes with different objects. In summary, class variables are shared among all instances of the class. As in the previous example, we used wheels equals to 4, while object variables are unique to each instance. As it. Okay, let's see the next topic, special methods in Python. Okay, what are the special methods in Python? In Python, special methods are also known as dunder methods or magic methods, which allow you to define how objects of a class behave in certain situations. These methods are surrounded by double underscores, hence the name dunder methods. Here are some commonly used special methods in Python. First one is init method. It is also known as initialize. This is an initialized method, also known as constructor. As we used this init method in the previous examples. It is called when an object is created from a class. It is used to initialize the attributes of an object. Here in this example, we created a class person and constructor init, and with attribute name, and we gave self.name equals to name. While creating an object, we passed a parameter John, and jo this John name is going to the constructor as an argument, and we place it in the name is constructor. Self.name equals to name. And second method is str method. This method returns a string representation of an object. It is called by the built-in str function and the printf function. For using every special methods, we need to use a constructor which is used for initialization. Here we use constructor init self.name equals to name, and the special method str underscore self, and we returned person name. Here the argument which is passed to the init method can be accessed by every other methods in the class. And third special method is REPR method. This method returns a string representation of the object that can be used to recreate the object. It is called by built-in REPR function and is typically used for debugging purposes. Here is an example. And len method. This method returns the length of the object. It is called by built-in len function. Here is the example in which we used list and we printed length of the list. Next one is get item method. This method allows you to define the behavior of accessing an element using square brackets. It is called when you use indexing or slicing on an object. Next, set item. Here we pass three parameters, that is self, which is already placed parameter, key and value. This method allows you to define the behavior of assigning a value to an object using square brackets. It is called when you use indexing or slicing of an object and assigning a value to it. Here is an example. to use set item method. Next one is del item. Here we pass an argument key to it. This method allows you to define the behavior of deleting an element using the del statement. It is called when you use del statement on an object's element. Here is an example which demonstrates the usage of del item method. Next one is get attribute method. This method is called when an attribute lookup fails. It allows you to define the behavior of accessing undefined attributes. So in this example, we asked person's age, but age attribute is not present in the class. So it returned attribute age doesn't exist. Next method is set attribute method. This method is called when an attribute assignment is made. It allows you to define the behavior of assigning a value to an attribute. Here in this example, we set person John age to 25. Here then output is came as a setting attribute age to 25. And the last special method which we are going to discuss now is del attribute method. This method is called when an attribute deletion is requested using the del statement. It allows you to define the behavior of deleting an attribute. Okay, these are just a few examples of special methods in Python. There are many more available for various purposes. Special methods provide a way to customize the behavior of your objects and make them more powerful and flexible. Next.
I am Bhavya. Now I am going to discuss about types of methods in Python. Methods in Python. In object-oriented programming, we have objects. These objects consist of properties and behavior. Furthermore, properties of the objects are defined by the attributes and the behavior is defined using methods. These methods are defined inside a class. These methods are the reusable piece of code that can be called at any point in the program. In Python, methods are the functions that are associated with an object and can manipulate its data or perform actions on it. They are called using dot notation, with the object name followed by a period and the method name. Methods are an important part of object-oriented programming in Python. Python offers various types of these methods. These are crucial to becoming an efficient programmer and consequently are useful for a data science professional. There are basically three methods in Python: instance method, class method, and static method. Firstly, we will discuss about instance method. The purpose of instance method is to set or get details about instances, which are objects, and that is why they are known as instance methods. They are the most common types of methods used in a Python class. They have one default parameter self, which points to an instance of the class, although you don't have to pass that every time. You can change the name of this parameter, but it is better to stick to the convention that is self. Any method you can create inside a class is an instance method, unless you specially specify Python otherwise. Let's see how to create an instance object. Instance method. Here we created a class named myClass. In that we defined an instance method with an default parameter self. For better understanding, we return a statement. This is an instance method. In order to call an instance method, you have to create an object or instance of the class. With the help of this object, you can access any method of the class. Here we create an object obj which is equal to myClass parenthesis, and we can access that instance method using obj.instanceMethod parenthesis. When the instance method is called, Python replaces the self argument with the instance object. That is why add parameter while defining the instance method. Notice that when instance method is called, you don't have to pass self. Python does this for you. Along with the default parameter self, you can add other parameters of your choice as well. Here we created a class myClass and we created an instance method now with additional parameter self, a. And for better understanding, we written a statement. This is an instance method with a parameter a. We have additional parameter a here. Now let's create the object of the class and call this instance method. Obj is equal to myClass. Now we can access that instance method using obj.instance method with a parameter 10. This is an instance method with a parameter a equals to 10. Again, you can see we have not passed self as an argument. Python does that for us, but have to mention other arguments. In this case, it is just 1. So we have passed 10 as the value of a. You can use self inside an instance method for accessing the other attributes and methods of the same class. Now we want to create a class myClass. In that class, we have to define an init constructor with arguments a and b. Self.a is equal to a, self.b is equal to b, and we want to define an instance method with default parameter self. For better understanding, we return a statement. This is an instance method and it can access the variables a is equal to self.a and b is equal to self.b with the help of self. Note that the init method is a special type of method known as a constructor. This method is called when an object is created from the class and it allows the class to initialize the attributes of a class. Here we can see that there are no attributes given to instance method, as instance method can get the attributes from the init constructor. This is an instance method and it can access the variables a is equal to 2 and b is equal to 4 with the help of self. With the help of self keyword self.a and self.b, we have access to the variables present in the init method of the same class. Along with the objects of a class, an instance method can access the class itself with the help of self.class attribute. Let's see how. Here we want to create a class with name myClass and we have to define an instance method. We want to put any statement for here. Now we will discuss about second type of method, that is class method. The purpose of the class method is to set or get the details of the class. That is why they are known as class methods. They can't access or modify specific instance data. They are bound to the class instead of their objects. Two important things about class methods. In order to define a class method, you have to specify that it is a class method with the help of @class method decorator. Class methods are also take one parameter CLS which points to the class. Again, this is not mandatory to the name the default parameter CLS, but it is always better to go with the convention. Now let's look at how to create class methods. Here we created a class with name myClass and you have to write in this we created a class method with the argument CLS and written a statement. This is a class method. With the help of the instance of the class, you can access any method. So we will create the instance of this myClass as well and try calling this class method. Here we created an object obj which is equal to myClass parenthesis and we can access the class method using obj.class method parenthesis. This is a class method. This works too. We can access the class methods with the help of a class instance or object. But we can access the class methods directly without creating an instance or object of the class. Let's see how. myClass dot class method parenthesis. This is a class method. Without creating an instance of the class, you can call the class method with class name dot method name parenthesis. But this is not possible with instance method, where we have to create an instance of the class in order to call instance methods. Let's see what happens when we try to call the instance method directly. Here we get an error which tells instance method missing one required positional argument self. Next, now we will discuss about last method in Python, that is static method. Static methods cannot access the class data. In other words, they do not access the class data. They are self-sufficient and work on their own. Since they are not attached to any class attribute, they cannot get or set the instance state or class state. In order to define a static method, we can use the @static method decorator. A similar way we use it to @class method decorator. Unlike instance methods and class methods, we do not need to pass any special or default parameters. Let's look the implementation. Here also we create a class with the name myClass and write a decorator @static method. And we have to define the static method and return a statement this is a static method. We do not have any default parameter in this case. Now how do we call the static methods? Again we can call them using object or instances of the class as object equals to myClass parenthesis object dot static method parenthesis. This is a static method and we can call the static methods directly without creating an object or instance of the class. My class dot static method parenthesis. This is a static method. You can notice the output is same using both ways of calling static methods. Here to summarize that an instance method knows its instance. A class method knows its class. A static method doesn't know its class or instance. This is all about types of methods in Python.
I am Divya. Today I am going to tell about garbage collections in Python. Python memory allocation and deallocation method is an automatic. The user does not have to pre-allocate or deallocate memory similar to using dynamic memory allocation in languages such as C or C++. Python uses two categories for memory allocation. The first one is reference counting and second one is garbage collection. Garbage collection is a memory management technique used to programming language to automatically reclaim memory that is no longer accessible or in use by the application. Now let's see about the generalization garbage collection. When attempting to add an object to a reference counter, a cyclic reference or a reference cycle is produced. Because the object reference counter would never reach zero, a reference counter cannot destroy the object. Therefore, in situations like this, we employ the universal waste collector. It operates and releases the memory used. A general garbage collector can be found in standard library GC module. Now when coming to the automatic garbage collection of cycles, the reference cycle takes computational work to discover. Garbage collection must be scheduled activity. Python schedules garbage collection based upon the threshold for object allocation and object deallocation. When the number of allocations minus the number of deallocations is greater than the threshold number, the garbage collection is done. One can inspect the threshold for new objects by importing the GC module and asking for the garbage collection threshold. When coming to the example, when we import GC to get the current collection, print garbage collection thresholds, GC dot get threshold parentheses threshold as a tuple, then we get output garbage collection threshold as 710. There are four types of garbage collections in Python. First one is manual garbage collection. GC dot disable parentheses to disable the garbage collector. And the next one is GC dot enable parentheses to enable the garbage collector. And the second one is the forcing garbage collection. In this, we can manually trigger a garbage collection using the GC dot collect parentheses function. This can be useful in case where you want to force immediate garbage collection instead of waiting for an automatic garbage collection to occur. The example for this is when we import GC or GC dot collector parentheses to trigger a garbage collection. And the third one is inspecting garbage collector settings. In this, we can inspect the current setting of the garbage collector using the gc.getThreshold parentheses function, which returns a tuple representing the current threshold for generation 0, 1, and 2. When coming to the example for this, input gc.threshold parentheses to get the current garbage collector thresholds. Print thresholds. The output is 710. When coming to the last type, settings garbage collector thresholds. You can set the thresholds for the garbage collection using get gc.setThreshold function. This allows you to manually adjust the threshold for different generations, which can affect the frequency of the garbage collection. And the example is the input gc.setThreshold 500 5 and print garbage collector threshold set. In thresholds, gc.threshold parentheses to get the current garbage collector thresholds. Print current thresholds. And the output for this is garbage collector threshold set, current threshold 500 5. Now let us explore some advantages and disadvantages of garbage collections in Python. The first one is automatic memory management. To avoid memory leakage or lower by change of running out of the memory, the Python garbage collector automatically removes the objects that are no longer referenced. Memory management made easier. The garbage collector frees developers for having to manually manage memory so that can concentrate on creating code, making Python is higher level and more practical language for developers. Now when coming to disadvantages, the first one is impact on performance. Although the garbage collector is designed to efficiently clean up the unused memory, there may still be some CPU consumption and execution time overhead, particularly when working in a large number of objects. And the next one is the difficulty of memory management. Although Python's garbage collector makes managing memory easier, using it successfully may still necessitate knowledge of the concepts like object lifetimes, object references, and garbage collection algorithms. So this all is about the garbage collections in Python. Thank you.